This is solution 2 of problem 22. Well, since we're dealing with complex numbers here of z, we can say z1 is equal to a plus bi, and z2 equal to, what is that? That's going to be d minus bi. It's still these values, they're just again flipped around. Okay, now earlier in the video, the previous solution, we proved that z1 times z2 is 10. So we can now say that a plus bi times d minus bi is 10. Okay, we have that. Upon multiplying that out, we get that this is AD minus ABI plus, plus DBI plus B squared I squared. Minus B squared I squared. Now, what we can do here is, we know the quantity I squared is -1 because I represents the imaginary number, the square root of -1. When you square that, it's positive. So this in turn becomes a plus b squared. And that is equal to 10. And what you can do here is really all just simplify this down, because this just becomes a squared plus b squared equals 10. This is also equal to 10. You can cross everything out because it's all dealing with i's and d's is the same. So a squared plus b squared is equal to 10. That's nice. Now, you know that a squared plus b squared is 10. I've been keep on saying that for some reason. But now, what we can do here is say 1 over z1 specifically. That is going to be, well, now 1 over 10, because instead of, we know that z1 is now supposed to, actually, yeah, 10 a plus bi. When you fully simplify it, this would be the square root of 10, but we have to multiply it by z1 on both the top and the bottom to get it into this form. Now, we can do the same thing. 1 over z2 is equal to a minus bi because it flips. That's over 10. Now, earlier in the first solution, we showed that it's basically a trapezoid, I guess. Trapezoidal shape. There. Yeah, it's area we're looking for is a trapezoid. Is a trapezoidal-like shape, if I can draw it. There we go. Okay, now what we can do is we want to find the length of the short base. The short base, the short one, this is going to be a plus bi over 10 minus a minus bi over 10. This turns out to be b over 5. Now, we can do the same thing with the long side. And the short side, b over 5. The long side, vice versa, long side is going to be, well, now we're subtracting these whole quantities. So a plus bi minus a minus bi. I forgot to mention that it's the absolute value of it, because you only want the positive value you can't have a negative side value. That would be quite impossible. And this value, alongside, will be just 2b. So this is 2b. Okay. Now, we want to find this little height here. So say the height is variable h to help us solve it. H is equal to a minus 9/10 and of a, and why is that 9/10? Well, it's because we have a z value here that's 10/10, and this 1 over z is at 1/10, so we want this remaining value here. Okay, so we have an expression for the height. Okay, and now we can find an area formula for this triangle. The area is going to be 1/2 times 2b plus b over 5 times 9a over 10. Area formula gets us 99ab over 100. Since it's asking us to maximize this value here, the only thing we can maximize is this 99. Area is equal to 99ab over 100. So asking us to maximize the area, all we can do is maximize this AB here. How do we do that? We can say squared plus b squared equal to this equation, a minus b squared plus 2ab is 10. Now, solving this equation, we find that when a equals b is the square root of 5, and since c is z1 plus z2, again, we can do the same thing, approximate it to 4.5, our answer.